Good morning. Today we are going to work through Lesson 4.5, Writing Rational Equations. We're going to start with a couple warm-up questions, and the warm-up questions are going to involve solving rational equations. We learned yesterday that when you solve a rational equation, one of the methods can be finding the least common denominator and multiplying both sides of the equation by the least common denominator to clear the denominator. Looking at this problem here, the LCD that would encompass the problem is x times x plus 1. So I'm going to make a parentheses around both sides of the equation and multiply by the least common denominator. What's going to happen is I then take that LCD and multiply it into the binomial on the left and multiply it into the fraction on the right. What happens to the first term in the binomial on the left is the denominator clears and you're left with x squared. The second term in the binomial, the x clears from the denominator and you're left with minus 4 parentheses x plus 1. Set equal to, on the right, the x plus 1 will clear from the denominator and you're left with negative 2x squared. Distribute on the left, x squared minus 4x minus 4 equals negative 2x squared. Add 2x squared to the left-hand side to set it equal to 0. That gives you 3x squared minus 4x minus 4 equals 0. Then we factor to find the solutions. 3 times negative 4 is negative 12. Two numbers that multiply to give you a negative 12, add to give you a negative 4 would be negative 6 and positive 2. You drop your terms and make a 4-term polynomial. 3x squared minus 6x plus 2x minus 4. Factor by grouping. The GCF of the first group is 3x. On the inside is x minus 2. The GCF of the second group is a positive 2. On the inside is x minus 2. Your factors are 3x plus 2 times x minus 2. Set your factors equal to 0. Your solutions are potentially negative 2/3 and positive 2. You check back in the original equation. If either solution makes the denominator 0, you would reject the solution or both solutions. In this case, neither solution is rejected. Neither solution makes the denominator 0. So your final answer is x equals negative 2/3 and x equals 2. Next problem. Same type of problem. You look and you find what is your least common denominator. Your only denominator is x plus 1, and then the 8x is essentially over just a 1. So your LCD is going to be x plus 1. Multiply by x plus 1 on both sides of the rational equation. That gets distributed into the binomial here and here, and it gets distributed here. Okay? The first term, there is nothing to cancel in the denominator, so we set it up 8x parentheses x plus 1. In the second term, the x plus 1s will cancel, and you're left with plus x equals, on the right-hand side, the x plus 1s will cancel, and you're left with negative 1. Distribute and combine like terms. 8x squared plus 8x plus x equals negative 1. 8x squared plus 9x equals -1. Add 1 to the left and set it equal to 0. Factor in order to find the solutions. 8 times 1 is 8. Two numbers that multiply to give you 8, add to give you 9 are 8 and 1. Make a 4-termed polynomial. 8x squared plus 8x plus 1x plus 1 equals 0. Factor by grouping. GCF of the first group is 8x. On the inside is x plus 1. GCF of the second group is positive 1. On the inside is x plus 1. Your factors are 8x plus 1 times x plus 1. When you set your factors equal to 0, you will then get your potential solutions. The first potential solution is -1/8. The second potential solution is x equals -1. Look back up in your original equation. You cannot accept a solution that would make the denominator 0. The only solution that would work for this particular rational equation would be x equals -1/8, because -1 would make the denominator 0. So we reject this solution. It is considered to be extraneous, and your only answer is here. Okay? Let's move to the content, the new content of the lesson, writing rational equations. First question style. Jesse pitches for the baseball team and wants to improve his batting average before the county all-stars are selected. To date, he has 10 hits out of 40 times at bat. Batting average is the ratio of hits to at-bats. Write a ratio that expresses Jesse's current batting average for this season and express the ratio in decimal form. Okay, so we're going to go down here. This is what I want to focus on here. He wants to improve his batting average to 0.320. If he gets a hit every time he bats, his new batting average would be 10 plus x over 40 plus x, where x is the number of future hits in as many times as at bat. Write an equation to determine how many consecutive hits he needs to bat 0.320. Okay, so what we're going to do is we're going to take the rational expression 10 plus x over 40 plus x, and we're going to set it equal to 0.320, which as a fraction is the same as 32 hundredths. Once I create that fraction, I can clearly see I have created a proportion, two fractions set equal. To solve a proportion, we cross multiply. So I'm going to cross multiply here and here, which creates the equation for us 100 times 10 plus x equals 32 times 40 plus x. I distribute 1,000 plus 100x equals 32 times 40, which is 1,280, plus 32x. I'm going to move variables to one side, numbers to the other, so I'm going to subtract 32x to the left-hand side and subtract 1,000 on the right, which gives us 68x equals 280. I'm going to then divide both sides by 68, which gives us x is approximately 4.118. Now, what that means is if he gets 4 consecutive hits, that would bring him to 14 out of 44, which when you divide 14 divided by 44, you get 0.31818 repeating. Okay, so the 1/8's repeating. So if they took batting average and rounded to the nearest hundredth, it would be 4 more hits. Okay, if they didn't, he would need 5 to then get 0.333, 15 out of 45. Okay? Okay, let's do a similar problem. Anne and Maria play tennis almost every weekend. So far, Anne has won 12 out of 20 matches. Perfect. Okay, so let's highlight that. 12 out of 20. How many matches will Anne have to win in a row to improve her winning percentage to 75%? Okay, so we're going to set it up just like we used Jessie's batting. So far, she's gotten 12 out of 20. We want to know how many matches in a row, so plus X, top and bottom, to improve to 75%, which is 75 hundredths, right? That's the same thing as 0.75 or 75 hundredths. Then you create your proportion and you cross multiply. We're going to cross multiply here and here. Okay, so we're going to set it up 100 parentheses 12 plus X equals 75 parentheses 20 plus X. Distribute 1,200 plus 100X equals 1,500 plus 75X. Oops. Variables to one side, numbers to the other. Okay, and we get, subtract 75X here, subtract 1,200 here, that goes away. Ooh. That goes away and that goes away. 25X equals 300. Divide both sides by 25. X equals 12. Anne will have to win 12 matches in a row to improve her percentage to 75%. Okay, next question says, how many matches will she have to win to improve her winning percentage to 90%? We're going to set it up the same way. 12 plus X over 20 plus X equals 90% is 90 hundredths. Percentage out of 100. Okay, cross multiply because you've created a proportion here and here. 100 times 12 plus X equals 90 times 20 plus X. 1,200 plus 100X equals 1,800 plus 90X. Sorry, the X is supposed to be there. Okay, subtract 1,200, subtract 90X. You get 10X equals 600. Divide by 10, X equals 60. So if Anne wants a 90% winning percentage, she needs to win 60 matches in a row. Okay? Question C says, can Anne reach a winning percentage of 100? Well, let's think about this logistically. If we were told at the beginning that she has won 12 out of 20 matches, She will never reach 100% winning percentage because she has already lost 8 matches. No, not possible. She's lost 8 matches already. Okay? Letter D says, after Anne has reached a winning percentage of 90% by winning consecutive matches, as in part B, okay, so she had to win, let's see, it says part B, she had to do 60 consecutive matches. How many matches can she now lose in a row to have a winning percentage of 50? Okay, so it said that she had to win 60 consecutive, which would make her ratio 72 out of 80. 72 out of 80, right? 72, if we set that up, 72 divided by 80 gives us 0.90. Okay, and that was when all we did to get 72 out of 80 was add 12 plus 60 over 20 plus 60, because we said she had to win 60 in a row, and that gave us 72 80ths. Now the question says, how many matches can she now lose to have a winning percentage of 50%? Okay, so let's set this up. 72 out of 80 plus x. This time I'm only adding it to the bottom because we're assuming she's not winning anymore. We're trying to figure out how many can she lose in a row to equal 50 hundredths, because we're looking for her winning percentage to become 50%. Okay, we cross multiply, we've created a proportion. 7,200 equals 4,000, 80 times 50 plus 50x. Okay, I just distributed in. Subtract 4,000 from both sides, and you get 3,200 equals 50x. Divide 3,200 by 50, and she can lose 64 matches in a row in order to drop her winning percentage to 50. Okay, if she loses the next 64 matches, she'll drop from a 90% winning percentage to a 50% winning percentage. Okay, all right, we're going to move to some work rate problems. Okay, first question says, working alone, Christine can put together a 500-piece puzzle in 4 hours. Christine's mom takes 2 hours to put together the same puzzle. Write and solve an equation to determine how long it will take to put the puzzle together if Christine and her mom work as a team. Okay, so there's a specific way that I'm going to show you how to set these problems up. Okay, so I'm going to give you that kind of formulaic method first. 1 over time alone plus 1 over time alone equals 1 over time together. Okay, so you're going to see us utilize this formula for the next few problems. Okay, here's what we're given. Christine's time is 4 hours. Christine's mom is 2 hours. Write an equation to determine how long it will take them if they work as a team. So our unknown is the time that it takes them together. So here's what we're going to set up. 1 over 4 plus 1 over 2 equals 1 over x. Okay? So I have Christine's time alone, her mom's time alone, and then what we're trying to figure out is how long will it take them together. Okay, same thing. This is solving a rational equation. I'm going to identify what is our least common denominator. I have a 4, a 2, and an x. So our LCD is going to be 4x. So I'm going to multiply both sides by 4x. On the left, I'm going to distribute 4x into both parts of the binomial, and 4x is going to be distributed here. So I get 4x over 4 plus 4x over 2 equals 4x over x. When I simplify, you'll notice all the denominators will go away. 4x over 4 gives you x, plus 4x over 2 gives you 2x, equals 4x over x. The x's go away, which leaves you with 4. X plus 2x is 3x equals 4. Divide both sides by 3. X equals 4/3. Okay, now understanding that our time is in hours. So 4/3 represents, let me just draw an arrow up here, 1 1/3 of an hour. If I want to be even more particular, I'm going to say it will take them 1 hour and 20 minutes together. 1 hour, 20 minutes, because 20 minutes is 1/3 of an hour. Final answer, x equals 4/3, or 1 1/3, or 1 hour and 20 minutes. Okay? Next question. Raj, Ebony, and Jed paint houses during the summer. Raj takes 5 hours to paint a room by himself. Ebony takes 4 hours, and Jed takes 3 hours. How long will it take them if they all work together? Okay, so I'm going to set it up. Raj alone, time alone, 1 over Ebony time alone, 1 over Jed time alone, equals 1 over time together. 1 over 5 plus 1 over 4 plus 1 over 3 equals 1 over x. Okay, now I need to find my LCD. I need something that 5, 4, 3, and x both go into. Okay, 3 is going to be the tough one. Let's use 60. Okay, let's multiply both sides by 60x. Okay, remember I'm distributing here, here, and here, and on this side. 60x over 5 plus 60x over 4 plus 60x over 3 equals 60x over x. If you noticed in doing that, all of the denominators will cancel. 60x over 5 reduces to 12x. 60x over 4 reduces to 15x. 60x over 3 is 20x. 60x over x is 60. Okay, 15 plus 12 plus 20 is equal to 47x. 47x equals 60. Divide both sides by 47, and we get 1.28. Divide by 47. X is approximately 1.28. 1 hour, and 28 hundredths of an hour. We could just leave it like that. Okay? Okay, another work rate problem. Working together, Aaron and Rosa can mow the lawn around the local library in 3 hours. Okay, so working together, their rate is 3 hours. Working alone, Aaron can mow it in 5 hours. Write and solve an equation to determine how long it would take Rosa by herself to mow the lawn. Okay, so let's set it up. 1 over Aaron's time plus 1 over Rosa's time, that's our unknown, equals 1 over the time it takes them together. LCD, 5, an X, and a 3, we're going to use 15X. Distribute here, here, and here. We get 15X over 5 plus 15X over X equals 15X over 3. 15X divided by 5 is 3X, plus 15X over X is 15, equals 15X divided by 3 is 5X. Okay? Subtract 3X to the right-hand side. 15 equals 2X. Divide by 2. And X equals 7.5 hours. Whew. Good thing Rosa doesn't have to work alone. 7.5 hours. Okay. Okay, another work rate problem. Working together, pipe 1 and pipe 2 can fill a tank in 12 hours. Pipe 1 takes twice as long as pipe 2 to fill the tank. Write and solve an equation to determine how long it would take for pipe 1, how long it would take for pipe 2 working by itself to fill the tank. Okay, so we're going to set it up. We'll go, I'm just going to label this here, pipe 1, pipe 2, and then together. Okay, so it takes pipe 1 twice as long as pipe 2. So it's unknown completely, but we know together they take 12 hours. Pipe 2 is X. Pipe 1 is going to be twice that time. So we have to label that 2X. Okay, so I had to go backwards a little bit with that one. My denominators are 2X, X, and 12. So our LCD is going to be 12X. Okay, distribute in 12X over 2X plus 12X over X equals 12X over 12. 12X over 2X would reduce to 6. The X's would cancel. Plus 12X over X would reduce to just 12 equals X. The 12s would cancel. Here, here, these canceled, and then the X's canceled. 12 divided by 2 is 6. 18 equals X. So pipe 2 working by itself would take 18 hours, which essentially means pipe 1 would take 36 hours. Whew. Okay. Okay, how many more work rate problems we have? Ooh, a couple more. That's okay. It's good practice. When Joe and John work together, they can wire a room in 8 hours. Okay, so work together, Joe and John, 8 hours. Working alone, working alone, Joe needs 12 hours. How long would it take John working alone to wire a room? Okay, so we're going to do 1 over 12, which is Joe's rate, plus 1 over x, which is John's rate, that's what we're trying to figure out, equals 1 over 8. Okay, we have denominators of 12, x, and 8. So we know we need x, but numerically, what do 8 and 12 lowest LCM, least common multiple, what's the lowest multiple 8 and 12 go into? I'm going to use 24 and x. So our least common denominator, 24x on both sides. Distribute in 24x over 12 plus 24x over x equals 24x over 8. 24x divided by 12 is 2x. 24x divided by x is 24 equals 24x divided by 8 is equal to 3x. Subtract 2x. 24 equals x. It would take John working alone 24 hours. That's an entire day. Okay. Working together. It takes Sam, Jenna, and Francisco 2 hours to paint a room. Okay, so that's their rate together. There's 3 of them. When Sam works alone, he can paint 1 room in 6 hours. So Sam, 1 over 6. When Jenna works alone, she can paint the room in 4 hours. Jenna, 1 over 4. Determine how long it would take Francisco, that's our unknown, if together they take 2 hours, 1 over 2. Remember, it's always 1 over time together is what it said equal to. 6, 4, x, and 2 are our denominators. So we need to figure out what can they all go into. Let's see. I'm going to use 12x. I know 6, 4, and 2 all go into 12, and then we need an x as well. Distribute here, here, and here, and also over here. 12x over 6 plus 12x over 4 plus 12x over x equals 12x over 2. 12x divided by 6 is 2x. 12x divided by 4 is 3x. 12x divided by x is 12 equals 6x. 5x plus 12 equals 6x. Subtract 5x. 12 equals x. Francisco would take 12 hours on his own. Okay. Okay. Another work rate problem, and then we have a couple different types, and then we'll be done. Okay. If 2 inlet pipes can fill a pool in 1 hour and 30 minutes, and 1 pipe can fill the pool in 2 hours and 30 minutes on its own, how long would it take the other pipe to fill the pool on its own? Okay, so together, 2 inlet pipes take 1 hour and 30 minutes. 1 pipe alone takes 2 hours and 30 minutes. Okay, so let's set that up. 1 over, I'm just going to use 2.5 because that's 2 hours and a half hour, 2.5, plus 1 over x, that's the one I'm looking for, the other pipe on its own, equals 1 over 1.5. Okay, so this is going to prove a little bit tougher. Let's see. 1.5 and 2.5. Let's do, we know their product, 1.5 times 2.5 is 3.75. So I'm just going to use their product and x as my LCD. So I'm going to do multiply both sides by 3.75x. I got 3.75 by multiplying 2.5 by 1.5. Okay, distribute here, here, and here. 3.75x over 2.5 plus 3.75x over x equals 3.75x over 1.5. Okay, so then I do 3.75 divided by 2.5, and I get 1.5x plus the x's cancel, 3.75 equals 3.75 divided by 1.5 is 2.5x. Subtract 1.5x, and I get 3.75 equals x. So what that means is 3 3/4, well, 1/4 is 15 minutes, so 3/4 would be 45 minutes. So how long would it take the other pipe? 3 hours and 45 minutes. I got the 45 minutes by doing 0.75 of an hour. 3/4 of 60 minutes is 45 minutes. Okay. All right, here we go. Next problem, a little different. Melissa walks 3 miles to the house of a friend and returns home on a bike. She averages 4 miles per hour faster when cycling than when walking. The total time for both trips is 2 hours. Find her walking speed. Okay, so for this type of problem, we're going to utilize the distance formula. Distance equals rate times time, but we're going to transform the equation a little bit and make it d divided by r equals t. Okay, so we know Melissa walks 3 miles to a friend's house at a rate of r. Okay, that's her rate. We don't know it. We're trying to figure it out. Her walking speed. She averages 4 miles per hour faster when she's cycling because she rides home on the bike. 3 over r plus 4 because she's 4 miles per hour faster. And her total time for both trips, so that's why I added them, is 2 hours. Okay, I'm going to put 2 over 1. All right, so looking across, I can see that I've created a rational equation. I'm going to multiply both sides of the equation by the LCD, r times r plus 4. Oops. Okay, distribute in here, here, and here. So the first side, the r will go away, and you're left with 3 parentheses r plus 4. Second term in the binomial, the r plus 4 will go away. You're left with 3r. Equals, nothing will go away because it's 2 over 1. So 2r parentheses r plus 4. Distribute 3r plus 12 plus 3r equals 2r squared plus 8r. Combine like terms, 6r plus 12 equals 2r squared plus 8r. Bring everything to the right-hand side. Bring everything to the right-hand side. Set it equal to 0. So I'm going to subtract 6r, and I'm going to subtract 12. So we get 0 equals 2r squared plus 2r minus 12. Divide everything by 2 as our GCF, and we get r squared plus r minus 6. I just divided everything by 2. Now we want to factor 2 numbers that multiply to give us a -6, add to give us a positive 1, r plus 3, r minus 2. Set them equal to 0. Our 2 potential r values, r equals -3, r equals positive 2. In the context of the problem, we are talking about Melissa's walking rate. A rate cannot be negative, so we have to reject this answer accept this answer and acknowledge that Melissa's rate is 2 mph, miles per hour. Okay? All right, home stretch, last problem. The difference in the average speed of two trains is 16 miles per hour. The slower train takes 2 hours longer to travel 170 miles than the faster train takes to travel 150 miles. Find the speed of the slower train. Okay, so couple things. Again, we are utilizing distance equals rate times time, but we're transforming the equation to be time equals distance divided by rate. The difference means subtraction. The difference in the average speed is 16 miles per hour. So I know I'm going to set it equal to 16. The slower train takes 2 hours longer to travel 170 miles. So the slower train, which is going to be the difference in the average speed, it's slower, 170 over t plus 2. And where I lost my train of thought. Sorry. The slower train takes 2 hours longer to travel 170 miles than the, oh, you know what? I did that wrong. We're not doing T equals D over R. Sorry. We're doing R equals D over T. Sorry, because we're doing time at the bottom, 2 hours longer. I just transformed it like the other one when it should be the other way. Sorry. R equals D divided by T, because this 16 is a rate, right? It's 16 miles per hour. Okay. Whew. The slower train takes 2 hours longer to travel 170 miles. So I did the distance is 170 over T plus 2. Then the faster train takes to travel 150 miles. So 150 over T. So we're going to solve for time, and then it wants us to find the speed. So then we're just going to plug it back in after we find that value. Okay, so we're going to multiply both sides by the LCD. This is over 1. So we're going to use T and then T minus 2. Or T plus 2, excuse me. Okay, distribute here, here, and here. The T will cancel here, which is 150 parentheses T plus 2, minus the T plus 2's will cancel, so you're at 170T, equals, nothing can cancel, so 16T parentheses T plus 2. Distribute 150T plus 300 minus 170T equals 16T squared plus 32T. Okay, combine like terms, and we get 300 minus 20T equals 16T squared plus 32T. I'm going to bring everything to the right. So I'm going to subtract 300 from the end, and I'm going to add 20T, okay, which gives us 0 equals 16T squared plus 52T minus 300. Okay, let's see. We need to make these numbers nicer. Can we divide? Well, we know we can divide by 2. Can we divide by anything bigger? Let's try. Let's do 4. Let's divide by 4. Divide by 4 just to make it easier to factor. Okay, which gives us, I'm going to change colors, green. Let's do 4T squared plus 13t. And then minus 75 equals 0. Oop, not 750. Equals 0. Okay, so we're going to go negative 75 times 4, negative 300. Okay, two numbers that multiply to give you a negative 300, add to give you positive 13. Let's see. 300. I need to grab a calculator. Quickest way to find factors in a calculator is the number divided by x. So I'm going to go 300 divided by x, and I need to be 13 apart. So I'm going to use 12 and 25. So I'm going to use positive 25. Actually, let me flip those around because that's a leading 4 there. Doesn't really matter. I could have factored, but it's going to make it easier for us. Let's use negative 12, positive 25. They'll multiply to give you negative 300, add to give you 13. Drop down 4t squared minus 12t plus 25t minus 75. Factor by grouping. GCF of the first group is 4t, on the inside t minus 3. GCF of the second group is positive 25, on the inside t minus 3. So our factors are 4t plus 25, I'll put them here, and then t minus 3. When you set your factors equal to 0, clearly the one on the left is going to be a negative, and you cannot have negative time. So t equals negative 25/4. You're going to reject that answer. This solution, t equals positive 3, you're going to accept that answer, t equals 3. Now let's go back and answer the problem for the context of the problem. And it says, find the speed of the slower train. So we're going to plug 3 in. Oops, didn't mean to delete. We're going to plug 3 here, right? Which is going to be 170 over, because that's the slower train. The slower train takes 2 hours longer, over 3 plus 2, which is going to give us 170 divided by 5, which is 34 miles per hour. So the speed of the slower train is 34 miles per hour. The speed of the faster train, it doesn't ask us, but we can do 150 divided by 3 because our t value is 3, and the speed of the faster train is 50 miles per hour here, plugging 3 in. Okay, that is it for today. Thank you for watching, and hopefully you took great notes with the problems that we worked through.